The line voltage at which using rubber gloves becomes dangerous is 3000 volts. Lineman's gloves are constructed with two layers of rubber. Firstly, there's an inner layer made of natural rubber. Secondly, an outer layer is made of synthetic rubber. The external leather layer serves to protect against cuts and abrasions, offering an additional layer of physical protection to the rubber layers underneath. Understanding voltage safety is critical for anyone working with electricity. Rubber gloves are a key piece of personal protective equipment, often referred to as PPE, designed to protect the user from electrical shock. However, it's essential to understand the limitations of rubber gloves and the voltage levels at which they provide adequate protection. The 3000 volt threshold is not an arbitrary number. It's based on safety standards and testing protocols that determine the breakdown voltage of the rubber material used in the gloves. Breakdown voltage refers to the voltage level at which the insulating properties of the rubber begin to fail, allowing current to flow through the material. When working with voltages exceeding 3000 volts, additional precautions and high-rated gloves are necessary. These may include using Class 1, Class 2, or higher-rated gloves, depending on the specific voltage levels involved. It's important to note that the voltage rating on the gloves indicates the maximum voltage at which the gloves are tested and certified to provide protection. This does not mean that the gloves will provide indefinite protection at the voltage level. The duration of exposure, environmental conditions, and the condition of the gloves themselves can all affect their ability to provide adequate protection. Regularly inspect rubber gloves for any signs of damage, such as cuts, punctures, or tears. Even small defects can compromise the integrity of the gloves and increase the risk of electrical shock. Before each use, perform an air test by inflating the gloves and checking for air leaks. This helps to ensure that there are no hidden punctures or defects that could allow current to pass through. In addition to using rubber gloves, it's important to follow other safety precautions when working with electricity. This includes de-energizing circuits before working on them, using lockout-tagout procedures to prevent accidental re-energization, and maintaining a safe working distance from energized equipment. Always use appropriate tools and equipment that are rated for the voltage levels involved. Never use damaged or defective tools, as they can pose a serious safety hazard. Wear appropriate clothing and footwear that provide insulation and protection from electrical shock. Avoid wearing jewelry or other metallic objects that could conduct electricity. When working in wet or damp conditions, take extra precautions to prevent electrical shock. Water is an excellent conductor of electricity, and even small amounts of moisture can significantly increase the risk of shock. Use ground fault circuit interrupters, also known as GFCIs, to protect against ground faults and electrical shock. GFCIs are designed to detect small imbalances in current flow and quickly shut off the power to prevent injury. Follow all applicable safety regulations and guidelines, such as those established by the Occupational Safety and Health Administration, or OSHA, and the National Electrical Code, or NEC. These regulations provide detailed requirements for electrical safety in the workplace and are designed to protect workers from electrical hazards. The two-layer construction of lineman's gloves, with an inner layer of natural rubber and an outer layer of synthetic rubber, provides enhanced protection against electrical shock. Natural rubber offers excellent flexibility and dielectric strength, while synthetic rubber provides superior resistance to abrasion, chemicals, and ozone. The combination of these two materials creates a glove that is both comfortable to wear and highly protective. The leather outer layer of lineman's glove serves to protect the rubber layers from physical damage. Leather is a durable material that can withstand the rigors of field use, protecting the rubber from cuts, punctures, and abrasions. The leather layer also provides a better grip, making it easier to handle tools and equipment safely. It's important to select the correct size of rubber gloves to ensure a proper fit. Gloves that are too small can restrict movement and increase fatigue, while gloves that are too large can be cumbersome and difficult to control. Use a glove sizing chart to determine the correct size based on your hand measurements. When storing rubber gloves, keep them in a cool, dry place away from direct sunlight and heat. Exposure to extreme temperatures can damage the rubber and reduce its insulating properties. Store the gloves in a protective bag or container to prevent them from being damaged by sharp objects or chemicals. Regularly inspect the gloves for any signs of deterioration, such as cracking, hardening, or discoloration. If the gloves show any signs of damage, replace them immediately. Do not attempt to repair damaged rubber gloves, as this can compromise their integrity and increase the risk of electrical shock. Always follow the manufacturer's instructions for the care and maintenance of rubber gloves. This will help to ensure that the gloves provide the best possible protection and last for as long as possible. When working with high voltages, it's essential to have a qualified observer present who can provide assistance in case of an emergency. The observer should be trained in CPR and first aid and should know how to safely de-energize equipment in the event of an electrical shock. Consider using voltage detectors to verify that circuits are de-energized before working on them. Voltage detectors can provide an audible or visual indication of the presence of voltage, helping to prevent accidental contact with energized equipment. Always treat electrical equipment with respect and follow all safety precautions. Electricity is a powerful force that can be dangerous if not handled properly. By understanding the risks and taking appropriate precautions, you can significantly reduce the risk of electrical shock and injury. Remember that the 3000-volt threshold is a critical safety benchmark for rubber glove usage. Always use appropriate gloves and follow all safety procedures when working with electricity. Your safety and the safety of others depend on it. Furthermore, it's crucial to understand the different classes of rubber gloves and their corresponding voltage ratings. These classes are defined by standards organizations and specify the maximum voltage levels at which the gloves are designed to provide protection. Class 0 gloves are typically rated for a maximum use voltage of 500 volts alternating current, or AC. These gloves are often used for working with low voltage circuits and equipment. Class 0 gloves are rated for a maximum use voltage of 1000 volts AC. They are suitable for working with slightly higher voltage circuits but still require caution and adherence to safety procedures. Class 1 gloves are rated for a maximum use voltage of 7500 volts AC. These gloves are commonly used by electricians and linemen for working on medium voltage distribution systems. Class 2 gloves are rated for a maximum use voltage of 17,000 volts AC. They provide a high level of protection for working on higher voltage systems. Class 3 gloves are rated for a maximum use voltage of 26,500 volts AC. These gloves are used for working on high voltage transmission systems. Class 4 gloves are rated for a maximum use voltage of 36,000 volts AC. They provide the highest level of protection for working on extremely high voltage systems. When selecting rubber gloves, it's important to choose the appropriate class based on the voltage levels you will be working with. Always err on the side of caution and select a glove with a higher voltage rating than necessary. It's also important to consider the specific tasks you will be performing when selecting rubber gloves. For example, if you will be working with sharp objects or abrasive materials, you may want to choose gloves with a heavier duty construction or additional reinforcement. In addition to voltage rating and construction, it's also important to consider the length of the gloves. Longer gloves provide more protection for the arms and shoulders, which can be important when working in confined spaces or near energized equipment. When using rubber gloves, always inspect them carefully before each use. Look for any signs of damage, such as cuts, punctures, tears, or discoloration. If you find any damage, do not use the gloves. Replace them with a new pair. It's also important to perform an air test on the gloves before each use. To perform an air test, inflate the gloves by trapping air inside and rolling the cuff towards the fingers. Then listen carefully for any air leaks. If you hear any air leaks, do not use the gloves. Replace them with a new pair. When working with rubber gloves, always wear them with leather protectors. Leather protectors provide additional protection against cuts, punctures, and abrasions. They also help to extend the life of the rubber gloves. It is important to remember that rubber gloves are not a substitute for safe work practices. Always de-energize equipment before working on it, and follow all applicable safety regulations. In conclusion, Understanding the voltage threshold for safe rubber glove usage is crucial for electrical safety. The 3000 volt level serves as a critical benchmark. Lineman's gloves, with their layered construction, offer enhanced protection. Always prioritize safety and follow proper procedures when working with electricity. Consider the following best practices for ensuring electrical safety. Firstly, implement a comprehensive safety program. This program should include regular training, clear procedures, and readily available safety equipment. Secondly, conduct thorough risk assessments before commencing any electrical work. This assessment should identify potential hazards and outline the necessary precautions. Thirdly, prioritize the energization whenever possible. Always de-energize circuits and equipment before working on them, and use lockout-tagout procedures to prevent accidental re-energization. Fourthly, use appropriate personal protective equipment. This includes rubber gloves, safety glasses, and insulated tools. Fifthly, maintain a safe working distance from energized equipment. Use barriers and warning signs to prevent accidental contact. Sixthly, never work alone when performing electrical work. Always have a qualified observer present who can provide assistance in case of an emergency. Seventhly, report any unsafe conditions or near misses immediately. Prompt reporting can help to prevent accidents and improve safety. Eighthly, stay up to date on the latest safety regulations and guidelines. The electrical industry is constantly evolving, and it's important to stay informed about the latest safety standards. Ninthly, participate in regular safety meetings and training sessions. These meetings provide an opportunity to discuss safety concerns, share best practices, and reinforce safety procedures. 10thly, foster a culture of safety in the workplace. Encourage employees to prioritize safety and to look out for one another. By following these best practices, you can create a safer work environment and reduce the risk of electrical accidents. Finally, remember that electrical safety is everyone's responsibility. By working together, we can make the electrical industry a safer place for all.